what I want to talk about today is modeling uncertainty. With all of the microservices and cloud initiatives going on, and reactive programming, whether you're using the actor model or any sort of RX Java or one of those variants, there's a lot of power in that approach, but there's also the uncertainty of not knowing, where things stand at any given time. Did someone receive my message? Have they replied to me? Messages are received out of order. What do we do about all those things? So I'm going to go through some of the ideas that I've used. Maybe you have some other ones that you'd like to share after my talk. I'd be very happy to hear about those. But I think what I am proposing here is a very simplistic approach, and as you know, I like to sort of pride myself on being the simplest, right? Or the person who makes things as simple as possible. In fact, I may disappoint you in this talk because you're going to find the solutions so simple that they may seem underwhelming to you. But in fact, that's actually my goal, because I want to show you that these techniques don't have to be difficult, even though I see people using techniques that are quite complicated. So the essence of domain-driven design, as Eric pointed out last night, is the bounded context with a ubiquitous language. Nothing really has changed about that in, what did he say, 14 years, I think? And that's a good thing. They're very powerful tools. And whether or not you're using the tactical patterns that Eric codified in his book is really not the important thing. It's really about tackling complexity with bounded contexts, speaking a ubiquitous language, and reflecting that in code. Another very powerful tool that we have at our disposal is context mapping. Context mapping, or maps between contexts, are actually vital to a project, and that is because you have to understand which other bounded contexts you are integrated with, because no single bounded context, as in core domain, will stand alone. Practically speaking, there will always be multiple bounded contexts in any complex system that you're working on. So you have to know basically the lines between the contexts. Now, don't confuse yourself or limit what the line means. Between these contexts, the line actually represents not only a technical integration, style or technique, but also the team relationships that exist between the two contexts. This is very important, because if we left it alone, to context mapping being the job of just telling us, do we use RPC, do we use REST, do we use messaging, that doesn't tell us much. The really important parts, I think, of context mapping is understanding who am I integrating with, not just what am I integrating with, or what tool am I using to integrate, but is the team that's on the other side of the line on my side, right? Are we in a partnership? Earlier today, there was a reference to Eric's three-legged race analogy about partnership. And I thought that the comment, I don't want to find fault with anybody's work or statement, but it was deemed negative because two individuals are in a three-legged race, so to speak, being the two partners in two different bounded contexts, being two different teams. Now, I actually think that partnership is an extremely important team relationship to have on a context map when you are dependent on each other in an early microservices effort, because you're going to support each other. Your events are extremely important to the other bounded context, or your commands toward that other bounded context are extremely important to them, and vice versa, so likewise. So knowing whether you're in a partnership or whether you are in a customer-supplier relationship, whether you're a conformist. So if you're integrating with, kind of the 900-pound gorilla, you have to know that it's not your partner. And you can conform to their API, to their model, but it's going to cost you something. It's going to cost you some clarity in your own model, because you're going to have to do things their way, not the way that you might like to do. And it also makes you think about the budget for what is this going to cost us to consume their model versus anti-corrupt their model and translate their model into our model, right? So knowing these relationships are extremely important, and I don't think that you can say that there is one that has an advantage over the other in the right setting, because you need to make sure that you have the context map relationships for the right setting. What situation are we in our project? And depending on the situation that we're in, we should really strive to have maybe a partnership relationship. What if we can't? What will it cost to be in the customer position with the supplier? So think about those things. Very, very important, powerful tool to use, and it can save you a lot of grief. So what I see, at least in my world, is a trending toward reactive systems. And I'm not talking about just reactive microservices, as in a single microservice that internally is reactive because it uses messaging between components internally. But we're also talking about building entire systems that are reactive. And I don't think this is anything extremely new, because Eric was far ahead of the industry when he introduced us to eventing in the first place, and the fact that bounded contexts would be separated in many cases from one another, and would have to react to things that happened in the past, and then bring various parts of the subsystems into harmony. So reactive systems continue to grow, and as I'll explain a little later too, I think that this is quite important, because the reactive is also now happening inside the bounded context, okay? And I'll show you how that works. Now, with the microservices and separate bounded contexts comes uncertainty. Here's what I mean by that. So we would like to think, right? I mean, if you just, as an individual, think, which would you rather deal with? If you know that event 1 went into its event journal first, and event 2 went in second, and event 3 went in third, wouldn't you just love to see event 1 show up first, event 2 show up next, and event 3 show up right after 2? Oh, life would be so simple, right? So what we get when we introduce microservices, whether as bounded contexts or as tiny, 100-line microservices, is this uncertainty of the very fact that you have no idea which order those events might be delivered in. And the very fact that at some point in time, even if you're using a messaging mechanism like Kafka that even sequences the order of events or messages or whatever you want to call them, and you think that you're going to consume those in absolute sequential order because that's how Kafka works. Ha, ha, ha. Right? So, if there is any chance at all of you receiving any of those messages out of order, you have to plan for them all being out of order. Right? So, otherwise, you're going to lose work. And it could be quite costly, quite dangerous to someone's life, who knows? So, I looked up the word uncertainty, and I thought that this was an extremely useful definition. Uncertainty is the state of being uncertain. Well, it sounds funny, but there is one thing to learn by this. Uncertainty is a state. Okay? And we know how to deal with state, usually. And so what I'm going to be talking about is state and how we can deal with the uncertainties of the state that we are in and some simple ways to reason about it. So uncertainty has synonyms such as unpredictability, unreliability, riskiness, chanciness, precariousness, changeability, variability. Doesn't that make you feel comfortable? Right? It's just something that you would just rather not deal with. I mean, think about just going to a restaurant. Do you want to go to a restaurant that is unpredictable in what it's going to serve you? Dinner tonight is going to be risky. Doesn't that sound delicious? Right? This restaurant is completely unreliable. Let's go there. Right? So uncertainty is really an uncomfortable situation. And that's what I want to emphasize, is that it is uncomfortable. And here's what we really like, right? Isn't this pretty much what all of us have grown up with, is blocking? Right? I have a client object, and a nod to Rebecca Werfsbrock over here. In her book on, this is great, You have Rebecca sitting right in the audience, and you forget the title of her book. Responsibility-driven design. I knew it would just take a second. Rebecca sort of, to me, simplified defining two objects that are collaborating together. One is a client and one is a server, right? Am I right, Rebecca? Yeah. So a client object doesn't mean that I have a remote object over here and I'm talking to a server over here over HTTP or something like that. It just means I have two objects and the client object is invoking a method of some kind on the server object. And the server object is a server because it's providing some service to the client, right? Okay, we can deal with that. But our brains just love the blocking part. And, we like to think that we know that when the server returns to us, we have full control, something has been accomplished, we can even comfortably check the state of what happened, and we can feel great. And, okay, sometimes exceptions happen, and we deal with those as comfortably as possible by just rethrowing and letting someone way up here deal with that, right? So, how do we get around this addiction that we have to blocking? There's another addiction that we have. It's the ordering of things, right? In school, we learned 1, 2, 3, 4, 5, right? And then you learned how to get past 10 into the teens and then 20s, but everything was ordered. And it makes us feel good about how things happen when we know the order that they're in. And we like to think that when I save an entity to a database or some kind of data, whatever, that that database belongs to me for that, few microseconds or milliseconds, and it's locked down. And all three of the nodes that I have on that database cluster belong to me, and everything is up to date right now. The certainty of that just feels good to us. But what happens with NoSQL stores? I mean, who here has used Cassandra? Lots of people? Well, a few anyway. What happens with Cassandra? Does Cassandra lock all three nodes in the cluster and say, we're going to make sure everything is consistent right now? No. There's uncertainty introduced just by the very fact that I could write to one node and someone else could query from another node and not see the write that I just made. Okay? Uncertainty. But I think that these kinds of ideas lead us to a thought that says, query less, event more. Events show you what happened at a specific point in time. And you don't know what the system is now, you only know, or the state was now, you only know what it was when this event happened. And it even has maybe a timestamp on it. But you're not fooling yourself by thinking that if I make a query to this database, I'm going to see the most recent data. Because all bets are off when you're using a highly distributed, maybe even continuous partitioning kind of database technology. I'm going to now show you something creepy. Actually, I'm going to show you the whole video, but I want to step you through it, not to convince you that this is what's going to happen, but to just show you what's going to happen. And actually, my wife and son last night told me, you got to show them the video. You can't just show them the snapshots of the video. But okay, I'm going to show you the snapshots first. This is a mask of Charlie Chaplin, okay? And it's a hollow mask. Well, masks have to be hollow. They have to be able to fit over your face. And what this mask is going to do is it's going to rotate. And as it rotates, your mind is going to be blown, right? You think, there's the side of Charlie Chaplin. Oh, there's even the inside of the mask. And then right when you get to the back of the mask, you think you're going to see a concave face. Ooh, what do you see? A convex face, right? Now, this is referred to, I don't know, I haven't studied this, so I'm not trying to be an expert at this. I'm just telling you it's called, I guess, a form of depth inversion. And the concave appears convex because, as my note here says, the sensory information of the present, what you are seeing right now, is canceled out by all of your knowledge of the past that says, I've never seen an inverted face before. That is why we can look at this thing and look at it and look at it, maybe even look at it for 20 years, and still see a nose projecting out toward us and the rim of the hat projecting out toward us. Maybe, like take your age and maybe say, if you divide your age by 2, if you looked at that inside of the mask continuously for the next, let's say, 20 or 25 years, and of course, for all the women in our audience, I know that that's only 18 years or less. But, why? Because we have seen faces like we are looking at each other's faces right now for so long that our brains cannot decide that I should actually be seeing a concave face. Now, let me show you the video just to prove how crazy this is. So you can look at this. It's on Science or Discovery Science for the Curious. And here we go. I think there may be even some sound. Maybe not. Doesn't matter. You'll see. Oh, wait, what happened? Okay, hold. What do I have to do I have to stop my slides, maybe? Let me stop my slides for a second. Does that work? Oh, no. How do I thought I was able to do video. Let me bring my slides back. Oops.
Do you have it embedded in here?
No, I don't. They're just there. It's just in my browser. Sorry, I thought I had this all checked out. Well, maybe it's not worth it. You could go look it up. Just search for, I think it's sort of like brain perception hollow mask. We'll probably find it. But let's give up on that. I want to move on. Yeah. I'll get back there. It's just, yeah. Thank you. Sorry for the trouble. Okay. All right, let's go forward. So the point I'm trying to make about this is actually, I think, helpful. When we are so used to seeing things in one way, like blocking, like synchronization, like strong ordering, our brains just want more of it. For us to give up on those ideas and actual working solutions that we've had for ages, tells us that this is uncomfortable. It's even uncertain to you just to even consider allowing this to happen. So it's going to take some, an adjustment in mindset, I feel, to even accept that these possibilities will be useful and allow you to make greater progress with software than you have in past years. Okay, so let me introduce you to an idea of the fortress. Okay, so when you encounter clear uncertainty and your brain doesn't want to deal with that uncertainty, what do? We try to develop an environment of certainty around the uncertainty, right? So we put a fortress around us, and it kind of looks like this. So an event comes in to our bounded context, our microservice, and we have a listener for that event, okay? In whatever way, it may be listening to all events or just one event, but that event arrives, and we have a listener for it. And we have no idea what order that event has been received in, or if we've seen it before. So what do? We put at the top a resequencer. And at the bottom, actually we probably use the bottom one first, which is the deduplicator, right? Okay, now that's going to make us feel comfortable. If that message has been seen before, our application will never know about it, right? So we throw that deduplicator in there, and what does it need? It needs some disk space, right? I mean, unless you've got just endless amounts of RAM to cache all the messages you will ever receive, because actually, frankly, what is your policy for deleting messages that you've already seen at some future time? What's a comfortable point for you to be in to say, I've already seen this non-commutative message, and I know I'll never see it again because 7 days has passed. Let's delete it from that internal store to make room for all the other messages that we haven't or may have seen yet, right? You can't do that. I mean, is 14 days enough? At what point do you feel confident that a non-commutative message that you receive will not add or subtract money from someone's account that they don't deserve to lose or gain? What about the resequencer? Okay, we not only run into a situation where we have to store these things off into the order in which we expect to see them, but how long is it going to take for event 2 to actually arrive? So when we finally get event 1, 2, 3, and 4 in the right order, we can release them and allow them to be consumed, right? Isn't that sort of how we'd like to reason about it? In fact, we could even conclude, you know what? Since we've already seen 1, 3, and 4, we can actually release event 1. That's okay, but we can't release events 3 and 4 until we see event 2. So what happens? Actually, whatever is interested in those events or ultimately influenced or mutated by those events, impacted by them in some way, they're just held up. So now we monitor this situation, and what do we find? Whatever was going to be impacted by this, well, it's only seen event 1. Why hasn't event 2, 3, and 4? Maybe it was never published from the publishing bounded context, right? We can go chasing situations that actually don't exist, and all that's happened is event 2 is latent, and we've held up 3 and 4. What can we do about that? So our attitude is sort of like, stop everything. Okay, I'm ready now. You know the problem with that? There is no now. Now is past. In fact, when you use the .NET framework, datetime.now, sorry, it's not now, right? So, I said something the other day that made people in my workshop laugh, and I thought it was just sort of like obvious, but one of the synonyms of uncertainty is having a second thought, So we might have even a second thought about, do I even want to write software anymore if this is where we're headed, right? So it might be something like, yep, distributed systems are here to stay. If you don't like them, change careers. Maybe open a restaurant. That's what I said, I don't know. I know developers who have started restaurants over frustration in the industry. Okay, why does uncertainty matter? Why is it so important to us? Because cores matter. We're writing multi-threaded applications, right? Our bounded contexts have more and more multi-threading in them. More cores are added to solve the problem that cores aren't getting any faster, or not much, okay? Every generation of processor is growing in speed, performance, by about 30%. So if every 2 years a new generation of processor arrives, we're way, way behind the curve of Moore's Law that was introduced in the 60s. The cloud matters. Now, I'm going to tell you 2 things about cloud and microservice that even sort of surprised me. I have a client who says they go to their management and ask for a new server. It's $5,000. Management says, nope. That's not a $5,000 server. We're going to have to hire 2 admins because our backlog in caring for our infrastructure is so bad that by the time we hire the new admins, that's going to be a $100,000 or $205,000 server, right? But you can have $100,000 to go get a new account on AWS, no problem. Isn't that interesting? And then think of this one. Okay, microservices matter. Why? Because you cannot, I mean, I'm not saying nobody can, but practically speaking, I see that companies can no longer hire entire teams to stick with one monolithic software project over the long term. People have to be moved and take on different roles, and so the very fact that microservices is an opportunity, because now one developer can work on potentially multiple microservices. And we can shift people around. It's actually an investment in our organization, in the people, because they learn more about a broader aspect of the organization. Latency matters because we're using networks. And when we use networks, things are going to break. Things get slow at completely inopportune times. We have network partitions that surprise us. You know what I found in one project? I was working at like 3 a.m. and I was testing something. I mean, this was years ago. I'm testing something and I'm thinking, this thing's going to fly, right? It's the middle of the night. Another one of my, sarcastic laughs. Why? Because all the backups are flooding the network, right, in the middle of the night. And now what I thought was just going to fly and I could be in bed by 3:30, right? Forget it. It took, much longer to run than I had anticipated. IoT matters, right? And all these things are cheap, right? Disk is cheap, memory's cheap, the cloud is relatively inexpensive. Processors, you can buy a really, really high-end, 24-way server for really very little money. I mean, compared to what it was even 10 years ago. Message-driven matters. Now, I just want to make one point about message-driven. Earlier today, there was a statement made about a conflict in, is our domain event-driven or is it command-driven? Why get in an argument over it? It's message-driven, right? We may have slightly different kinds of messages. They may mean something slightly different, but I think Martin Thompson has a very good way of saying it's just a message, right? Does he distinguish them? Evidently, he gets away without having to do that. Okay, so reactive systems are a thing, and uncertainty is a state. Now, if you go to this paper by Pat Helland, Life Beyond Distributed Transactions, it's an updated version of it, right? It's on the ACM website. You can look for it. And he says, in a system that cannot count on distributed transactions, so this is just one aspect of the uncertainty, the management of uncertainty must be implemented in the business logic. Yay, Pat Helland, right? Now, what Pat Helland introduces in this paper is an idea of an activity. I haven't even met Pat Helland. I don't know what he had in his mind when he wrote this, but this is what I envisioned, right? When he said activity, okay, he's talking about multiple entity partner relationships, right? So I have at least two entities and they're dependent on each other, and there are activities that are happening between the two, and you need to track the partner activities so that you know what's been done. Okay, makes perfect sense, and that's actually all that I'm talking about here today. But this is how I kind of saw what Pat Helland was talking about. I see kind of this set of partner activities, and this is for a single entity. And so I'm going to record an activity that has arrived from a partner, and with that activity, so I'm going to sort of keep a partner activity, right? And then I know it's a set, so if I try to record it again, it won't be added again. And I can also ask it, has this partner activity seen this partner activity before, right? So that's sort of how I see it. And I'm not saying that's what Pat Helen meant, but I'd like to see more than this, right? I want to take this further. I want to track complexity where, everybody, DDDers? Where? In the heart of the software, right? Right in the middle. I think it's going to be easier to do this, or simpler at least, maybe not easier, but I think it is less complex. So we want to develop an explicit model, and we're going to work in a core domain. Now, this is an interesting decision. Is this the core domain? I'm going over this specific kind of example in my workshops, which I just taught past few days. And what seems apparent at first is when we have, this is a P2P economy domain overall. And this is where you have a client, person. It's sort of a mom and pop helper. If you have a mom and pop company, and let's say that you're a client and you need some carpet installed in your living room, and so you go to a website and you make a job proposal. I need carpet installed in a 12 by 12 living room, and it's a plush carpet, and you provide these descriptions which end up being some keywords, and then you propose this job. You set a price, location, expectations like what's the due date, and so forth. And it seems like this is really important. This is where the money is going to be made, right? So we're going to put a lot of effort into this one. But as you look into this entire domain further, you've got pricing, scheduling, and fulfillment also involved. I think maybe actually core is the pricing. And this is really complex stuff because we have to understand across the services, the home services industry alone, what does it cost normally to get carpet installed? Is it a holiday? Is it evening? Is there an emergency situation with a clogged drain in your kitchen and 15 guests are going to show up in 2 hours, right? What if we could actually figure out a really smart way of charging people different amounts of money, which means our percentage goes up in the matchmaking between client and doer, okay? So I think actually maybe pricing, it may not be the only core domain, but it's at least a very important one, I think. Okay, so we're trying to solve some problems in this situation, and I have a few other examples, but think about this situation. You have a duplicate commutative message that arrives. Let's say that it's an event. The event arrives, and you've seen it before, and now a command, the event's going to be translated into a command, and the entity needs to safely react to that command. Our state already has a value in it. What do? We simply check to see if we already have a state, and if we do, we can emit an event, but here's a trick that you have to be careful of. You don't want to emit an event if you have already seen this command before, because then you're just adding to the uncertainty of the entire system. In fact, you may confuse. So here's a simple model for that. We have a progress model. Progress has some specs, which one of those specs is pricing denied. Okay, we get into a situation where a client says, I want my drain fixed at 7 p.m. tonight for $30, right? And the pricing says absolutely no way, not going to happen. So we add the spec to the progress, pricing denied, okay? Now notice that the spec is added and it may already be there, but it's a set so we know the fact that it may already be there. Okay, I know what you're thinking. What if we, emit a message or an event from our proposal entity or aggregate that says, actually in the case where we shouldn't. We'll get to that. Then you have the duplicate non-commutative. This is where you have to be even more careful because the state alone will not necessarily, or the state of the result, as in add $10 to something or subtract $20 from something, is not necessarily what what's going to help you out in this case. You'll probably have to keep a unique ID for that partner, right? But you can still keep that ID in a similar concept. So we can still use the progress, okay? And then notice at the with new spec, we can actually tell them we've already seen this, right? And that can actually be used in either case, either the commutative or non-commutative. We can tell whoever has used the progress, as in the proposal, we can say we've already seen this, and if we've already seen this, then we're not going to emit a new domain event. What about ordered sequence? This is where we expect to receive, like I showed you before, event 1, event 2, event 3, and we want to see them exactly in that order. Just let them through. As they arrive, let them through. You keep a state that keeps track of the steps that have been completed. Therefore, you know that the job isn't done yet, or the progress or whatever it is that you're tracking isn't done yet until all 3 steps have been completed. And so you simply ask, is the progress or is whatever completed? No, okay. But when it is completed, when we have all 3 steps completed, we emit a domain event. So the proposal itself can have an is completed, and an is completed is based on are we either in an acceptable state or an unacceptable state? Have we reached the point where we know, based on all the outcomes from the collaborating microservices or bounded contexts around us, have we reached the point where we know that this is at least a completed situation? And then we can ask, is it acceptable or unacceptable? What about the closest proximity? Okay, similar to the previous example, but now we're simply looking at the actual values of not just was it completed, but what about, in this case, the distance from our warehouse to some shipping location that has availability. So you have a proximity locator, you keep some distances, and you ask the distances, do you have all of your distances that we knew we were interested in finding? If we don't, we just let it go until we do have them. And then when we have a closest, when we are completed, we can ask for the closest distance, right? And then finally, I think this is the multiple choice first fastest, as in we're just going to take whatever answer arrives first, right? So we see an event, we could see 2, 3, 4 events, but we see event 2 first. We have to let event 2 win in this particular slide, since it lost in the other one. And we create a command, and we execute that command on the entity. And we now know what our closest distance is, and here's very similar code. In fact, we don't really necessarily need the is completed because we know it's complete, something arrived, so we know we at least have a first, right? Now, one thing that you have to consider is, what if one of these things never happens, right? That's sort of the missing piece of the puzzle here. What if it never happens? Well, a simple way to deal with that is to use a timer. So use a timer to track which entities. Maybe you want to have a timer for all entities that may be in this uncertain situation, or you might have a timer for each individual. And in keeping time frames and time stamps, for example, on the proximity locator and so forth, we can know what is the expectation for having all of our distance, or having at least a first distance, or in this case, the closest distance available. So we can time out on that. If the timeout leads to a point where the entire process has to fail, then we can intelligently and safely log and notify about that situation. It doesn't make it any better, but it is a business problem. Now, the thing that I want to sort of emphasize overall in this entire presentation is cloud matters. I said it. Microservices matter. It's part of developing software these days. Before, I think we have tried to ignore, and I don't necessarily say we all collectively, because I know that there are tremendous experts in this room who have figured this out a long time ago. But what we are facing is that this really needs to become a mindset of the core of the business. Let's actually model the uncertainty in the open with the business, and come up with solutions. Because when does this closest proximity time out? That's not up to me. I'm just a developer. That belongs to the business, right? So you have to involve the business in those kinds of decisions. Why not model the uncertainty and make it as simple as possible? Put it at the heart, instead of trying to create a facade like that you are not in an uncertain environment. In essence, you're embracing the uncertainty and you're saying, yep, that's what we got to do these days. That's what delivering software is all about. So let's make our best effort and model the uncertainty. So that's my talk.